I started with a terrain, and it looks like this. So I just have a small piece of LiDAR here with a hill in it. And if you take a look at this little cross section here, we have a very steep side hill. Now, unfortunately, the measure tool doesn't have a pop-up. You have to look into the home ribbon. There it is. It's 70% roughly. So it's a steep downhill slope. And I want to build a road that goes around this hill. And that's a classic example of trying to climb as fast as possible, and there's a steep side hill. The other possibility, which happens in the tropics, is that the material is just simply not, it doesn't support fill. It has poor integrity. It's full of clay, or I don't know. Anyway, often in the tropics, you can cut a full bench road, but you cannot build a road on fill. So even though the side hill may not be so steep, they still use full bench. Okay, so I went to the location module and I pegged in a road. So I'm not going to show the pegging process, show you the result. Just to find a grade. So first of all, there is no profile. The profile shown here is just the ground line. There's just the one point at the start, and the rest is the ground line. There's no vertical alignment design. And in the plan window, I have this label turned on, and I've got all this saved in my screen layout, so I don't have to do all this every time. But it's the L-line grade. And that label, when there is no vertical alignment, it shows you the average grade between horizontal alignment points. So if I go in here and edit this point and move it downhill, you can see that this grade went down and this grade went up. And I'm trying to get a 12% grade here. So if I just wiggle this around a little bit, I can say, okay, that's pretty close to a 12% grade. And I did that all the way up. I started down here and I worked my way up the hill, trying to keep it under or near 12%. And then at the top of my road, I just arbitrarily made it a little flatter. At the bottom of my road, of course, I have to have a small grade because I'm branching off an existing road, which is essentially flat. So you don't want a sudden grade break there. So the real result of using pegging is you end up with a ground line that's a constant slope. And that slope is 12%, my maximum grade allowed. Okay, so that's my horizontal alignment to start. Now I'm going to put in a vertical alignment, and I've already done that. So I'll just open the file. Again, this is not really the topic. So here's my horizontal alignment, and I put in a vertical alignment. It's very simple vertical alignment. We start with a little vertical curve at the bottom to go from a matching grade, 2.9%, up to my maximum grade, which is 11.9%, and then another vertical curve at the top to reach my final grade of 2.6%. Perhaps there will be a landing there or something. Now I don't need to touch the vertical alignment. It's finished. It's running at maximum grade. And if I want to modify this road, I need to modify the horizontal alignment. As you can see, my initial pegged alignment is producing large fills on the side of the road, where the fill slope is almost the same grade as the ground. I've got my profile set up to show the side slopes. You can see them down here, 84, there's minus 99, that's really steep. And you can also see them in the cross section. Here it's minus 96, I think it says there. And you can see it just by looking in the cross section. Okay, so I've got a steep side hill. I want full bench cut, and I can easily get that by modifying these horizontal alignment points. So I could pick this one up, move it over a little bit. Not quite far enough. I could move it a little further. There we go. That's full bench. Now you can actually do that in the section window as well. So if I set up my section window to allow horizontal alignment, don't do vertical at the same time. You'll mess up your perfect grade. Just horizontal. Then I can click in here, move it back and forth, and adjust the alignment, and very carefully watch so that I get my full bench cut and nothing more. And in addition, oh, by the way, you can't do that when there's curves. I'll come back to curves later. It makes everything harder. So it's a good idea to first do it without curves. And the other thing you can't do is the automatic, which I'm going to show you in a second. So down here, the cross section is not so steep, and fill is okay. Up here, it's very steep. We're up to minus 40%, and over here we're at minus 60%. So somewhere in this zone here, we need to have full bench. I arbitrarily chose 300 as my starting point. So after station 300, I want full bench cut all the way to the end, because the last cross section is also steep. And we've got a tool for this that does it automatically. In corridor operations, there's a thing called section balance. It does allow you to balance your cross sections, but in this case that would be impossible because we want full bench cut, and it also allows you to do full bench cut. So I want to move points horizontally. I don't want to mess up my vertical alignment. It's already good. I want to move horizontally to full bench cut from 300 to the end. And I only want to move the horizontal alignment points. Okay, so that automatic tool can really save you a lot of time. Takes a little while. I'm kind of surprised how long it's taking. I don't remember it taking a long time the last time I tried this. There it goes, done. So now you can see it's not perfect because when you modify one cross section, it messes up the one behind a little bit because the cross sections are perpendicular bisectors. So yeah, you can imagine if you get this one here perfect. Section balance operation, every cross section that was a horizontal alignment point should be full bench. Notice this little piece of text here, Control F adjusts a single point. That can save me a lot of time later. I'm going to remember that. They should all be full bench. If I move through the horizontal alignment, every single cross section should be full bench. But as you can see, they're not in general. There's a little, that one's wrong, for example. That one's okay. That one's not quite full bench. And the reason for that is technical, but essentially it's working from the beginning to the end, and it moves a cross section until it's perfect full bench, and then it moves to the next cross section and modifies it, which changes the angle a little bit of the previous cross section, and then it may no longer be full bench. But it's a very good starting point. Oh, here's a trick too. Right now my fill slope is quite steep. So if there's a bad section, I can see it. But sometimes it's not obvious. Like that isn't as obvious as that is. If I change my fill slope a little bit. Whoops. Just temporarily. So let's just do the right-hand side. My final slope right now is automatic, meaning it's using the fill slope defined in the fill material. Anyway, I'm just going to change it to be 2 to 1. As you can see, that will generate a sliver fill or an infinite fill. And if I do that and recalculate everything, then it becomes really obvious where my problem is. Just exaggerating the problem, I can go back and fix that later. It probably will, this operation will probably work better a second time. So if I just keep all the same settings and say okay, I'll probably get a slightly, because now it doesn't have to move as far, I should get a good result for every cross section. Oh, okay. There's still a few bad ones, but it's better than it was. Okay, now I can fix these manually, and that's easy. So here's a typical situation. If I'm in the horizontal curves panel, I can jump between horizontal alignment points. You can see they're both good. This one's good. No fill in the cross section. Next, this one's good. No sliver fill in the cross section. But there's one in between that's not good. So if I just use this arrow and go back, you can see, oh, there it is. And that kind of makes sense, right? I didn't have a point there before, and so it couldn't be adjusted to be full bench. It's just a straight line between those 2 points. I'm just going to go back to the middle or so, and then I can either move it horizontally by hand, or remember this thing here said that I could use Control F. Let's try that. So I'm sitting on this cross section here. There's no intersection point. I type Control F, and there, it fixed that one cross section. And unfortunately, there's another problem in between, and it's right next to this point. So what I'm going to do here is I'm going to just manually move it over a little bit, and that fixes up that section there. Similarly, I can go through, okay, that one's okay, that one's okay. Let's put a point right in the middle here, and then Control F, it's full bench.
Oh.
And it's not quite, I mean, there's another one in between that's a problem. I don't want to put too many points in. So what I'll do is I'll go back to this one, and I'll just move it a little bit further in, and then ahead to the next one, and move it a little bit further in, and there we go. Now, the whole point here is there's nothing wrong from a construction point of, or from a stability point of view with having the road way farther over, but it costs more money. So if I move this point over like so, I'm cutting more material than I have to. The cut area here is 63 square meters. If I was blasting rock, that would be expensive. Whereas if I move it over to just on the edge of full bench, I'm reducing that. So now it's only 45 square meters. So I've saved a few percent. So it's worth the trouble, probably, to try and get these as close to full bench as possible without going too far. Here I think I need another point, so I'm just going to type Control F and get another point there. Now, I don't want to put another point in between these. They're very close to each other. I'm just going to go back here, move this one a little bit, and that fixes that problem. Same here. I'm just going to go ahead to that point and move it back a little bit. There, that fixes that problem. And so it doesn't take long to get a reasonable horizontal alignment just by doing it by hand. In theory, the horizontal optimizer will do this, but the horizontal optimizer you would have to tell it to maintain the grade, right? You'd have to constrain the grade if you wanted to get this to work. Okay, so just without too much effort, I've managed to get this. I'm not sure why that reappeared. That's a weird situation. Okay, anyway, let's go there. This is 600 meters, and as you saw, the area of interest was about the last 300 of it. A few minutes, 300 meters doesn't take very long. If it was 30 kilometers, I mean, I managed to do 300 meters in a few minutes, so 30 kilometers would be maybe a few hours. Section balancing can get you started. Now, let's look at this with curves. So I'm going to put in a curve here. It's a different problem. So essentially, we've solved the problem here. We've found a solution where the total cut is 14,000, and I don't think that can be reduced. You know, I can easily increase it by moving a point up the hill. It's going to cut more, but I don't think we can reduce it. We've got the minimum cut here. Oh, one of the tricks that people often use is they get rid of the ditch. That reduces the volume, and then they slope the road outward so the water drains off. That's good as long as it doesn't snow, because when it's slippery, you slide off the hill, and it's very dangerous. But anyway, there are tricks to reduce the cut volume even further. But given that we must have a ditch, and this is the steepest we can cut the ground, and we must have the road this wide, we have minimized the volume. Let's put in some curves and see how that works. So here, I want to put a curve around here instead of having the road wiggling back and forth in and out of the hill. To do that, I will delete some of these. By the way, I should save this. And now I'm going to put a curve in. So if I delete a few of these points, and then add a curve, my horizontal curves panel. Let's put in the default curve. Oh, that's way too big. Let's try 50. I think we can go a little smaller than 50. Yeah. So you can see that we've got something that doesn't have any sliver fills except here. So I'm just going to modify this point. And oops, I deleted the curve because I went in here. Put the curve back again. There we go. Oh, okay. So I can modify this point with the mouse in the plan window, and it won't delete the curve. I'll just move it in a bit. There, and this one too. See what happened? I modified this one. The angle for that one changed because it's on the bisector, and it became a sliver fill. So then I have to also modify that one. Because there's no curve dependent on it, I can do it in the section window. Yeah, okay, so now if we step through our alignment, this is pretty close to full bench. Oh, but here we've got a big sliver fill. So now all I can do is move this point here, because that's dependent on the curve. And you can see I've got a problem there and there. Here, well, I think I can move this back a little bit. That's not a problem. Oh, and now I've only got a problem here. So if I just move the curve that way, oh, too far. Okay, I'm back just a tiny bit more. Good. And now it looks like I've accommodated that curve with everything being full bench. We got our daylight set here, and sometimes we've got a fairly large daylight. Sometimes we're pretty close to full bench. So our volume went up. If we look at the total now, it's gone up from 14,000 to 15,000. Nothing we can do about it. If we want to have a nice smooth curve and a long straight grade, then we're going to have some larger cuts. No way around it. Yeah, and here's another situation where we've got a real kink in the road. If we take that kink out to make it smoother and either put in a curve or not, the only way to do that, if I take this point out, then I'm generating a sliver fill, unless I move this point in a bit, and maybe this point too. Okay, now I've taken the kink out of the road, but my payment for that is some larger cuts. Yeah, that looks pretty good. And here's another place where I might want to put a curve. There's the classic bow tie from crossing cross sections on the uphill side, and it's not a wide road. It's just caused by the sharp turn here. So again, I'll put a curve on there. And we found 30 worked pretty good before. There we go. And exactly the same problem. To make that into a smooth curve, I had to make, oh, that's not so much of a full bench. That's funny. Oh, we're back. We're below. We're into the gentle slope here. Yeah. Okay. There's a lot of applications for resource roads where this is the kind of road they want to build. Sometimes, like I said, in the tropics, it doesn't matter where you are. You have to use full bench because the ground has poor integrity. Here on the coast of BC, and in fact, that's where this LiDAR came from. The problem is that the fill becomes unstable. And so you don't fill because it rattles down the slope and looks ugly and destroys the environment. And then you have to truck the material out. And they call that an end haul road because the material that you're cutting has to be hauled out to the end where they dispose of it in a spoil site somewhere or use it to build something else.